Between 34 and 36? 35. So if I told this, and these are in thousands, of course, remember, it's not 35 bucks. Yay. So if I told this guy you can expect about 35,000, that is much more honest. Maybe. Now, what's really pathetic to me and sad is that there are a lot of people on like the news or even online that are abusing people's misunderstanding of statistics and giving them the wrong thing at the wrong time. So the picture you get is completely skewed. Oh my God, this and this, holy shit, when really it's not being honest. But they know they can get away with that shit because nobody knows statistics. Shit. Except you guys. You're going to come out of this class, you're going to be like, You're going to take advantage of me. All right, maybe. You don't have to slap. I don't know. Okay, so that's median. I like it. So that should be straightforward. Again, it's got to be in order for it to make sense. Then we got two more. Mean, median, and then we got, I gave this away earlier. What am I doing? No, numbers. Mode. Anybody know what the mode is? Yeah, the number or the thing that occurs the most. I say or thing. What kind of data does the mean and median work for? Remember the two main types of data? The Q's. Quantitative, qualitative. Mean and median work for what kind of data? Probably the data we used. Not continuous discrete. It works for both of those. But it's either quantitative or qualitative. Which one? Quantitative. Qualitative is just words. And if I had tried to take the average of Hyundai and BMW, I don't know what that would be. Ford. No, I don't know. So mode is the one thing that works for qualitative data also. So if I went out to the parking lot and I saw 600 Fords, 400 Hyundais, I just like to say Hyundai, and 30 BMWs, what's the mode car type? Ford. Because that's the one that occurred the most. How does it work for data? I don't know. Oh yeah, I do. What's the mode? Okay. And there's no symbol for mode. I was telling my other class, one semester we made a symbol. Somebody said, can we make a symbol? Like, sure, what the hell? And they chose a capital M. I'm like, okay, fine. There's no symbol for it, really. Okay. What about this here? So it's called bimodal. Woohoo. It goes up to trimodal, and after trimodal, we just say there isn't a mode. Because a mode is trying to see where's the data clustering. And once it's doing it more than 3 places, it isn't really doing it. It isn't clustering somewhere. All right, what about this? I don't know, Jeff. 10, 10, 11, 11, 12, 12, 12. 12, it's a competition. Who wins? There wasn't a tie. 12 is on top. So don't tell me 10, 11, 12 because they all have repeats. No. 12 occurred the most. By the way, this is bimodal 11, 12. 12 won this one. Okay, not hard. All right, I like it. And then the last one, I don't think the book even talks about this, but I will anyway. Haha. What do you think this word would represent calculation-wise? Mid-range. Mid-range. What do you think? What's the range? High minus low. So what do you think mid-range would be? The number that's in the middle of the range. What sucks is range is minus. Because you're trying to see how far it goes. So that's subtraction. Mid-range is the average. How do I find the middle of two numbers? Take the average. And what does average involve? Addition. Oh, shit. So mid-range is high plus low. Become the word low. Divided by 2. That's it. So So if my data look like 10, 11, 12, 14, 16, 64, how would I find the mid-range for that data? Yeah, it'd be the low plus the high divided by 2. 74 divided by 2. Come at 2. Yes? No? Yes? Yes? Yes. I'm just going to say for you. You meant to say yes. It's not hard. You just have to remember it. Okay. How do you remember it? I don't know. Mid-range. The word tells you how to find it. Okay. Okay. Now, that should be not too taxing. Finding the average, you knew how to do that before you got to this class. Now you just know the symbols that go with it. Cool? Median, some of you guys knew that word before, but just remember the median's in the middle of the road. So it's the number that's in the middle. Mode, most, bam. Right? And then mid-range, again, the word tells you what to do. Okay, now, to get into this next section, we're gonna finish up chapter 2 incredibly. What time is it? Oh yeah, we got plenty of time. Okay, so, you guys know about a website called RateMyProfessors? Yes. Yes. I got to tell you a funny story. I was working on the East Coast. It's back in 2004, teaching out there at a college. And the professors all kind of learned about this website. And the next day, I went in there and I could tell that a lot of them had rated themselves. Right? I'll never forget this one guy, philosophy professor, really stuck up. And he had written, he's the essence of the essence. I'm like, yeah, that sounds like something a student would say. So anyway, real quick word about it. I'm not going to talk about that. That's not the main thing. But nowadays, if I don't get some bad reviews, I'm not doing a good job. So it's sort of like how I use. There's another website that you probably would be more interested in that tells you grade distributions for every teacher, because that's public domain knowledge. You have to pay money to get into it, and I'm not going to tell you what it is. Nah. Right. But let's say, does anybody know that existed? Anybody?
What is it?
Huh?
It talks about the
grade distribution for every teacher for every semester.
Oh.
You could actually call Grossmont and request that for any teacher. It's public domain knowledge. Hopefully you don't use it for evil. Like the teacher that gets nothing but A's and I won't know shit. Yeah. Alright, sorry. So let's say you're trying to pick between teachers and you've done all your research on RateMyProfessor and they're basically the same person almost. And then you look at this other website that I'm not going to tell you that I almost just told you. And you can see that they both give an average of C. And that's, all right, that's still not enough information to try to pick between the two, right? You guys kind of with me? A little bit? Have you all done something like this, right? Yeah. I know you have. Who's this guy? Let me go see what he is. Oh shit, everybody hates him. Right? And now you got this other website, if you find it, you can look at this grade distribution. So, also, one other thing. Let's say that we're at a 4-year institution. What's the difference between Grossmont College, community college, and a 4-year place? What's passing at community college? What would transfer? Up down to a C. Once you get to university, 4-year college, D- is passing. Remember that next time you're driving over a bridge. Well, please don't be the D- engineer. Got to put this together, right? Okay. So stay with me. So let's say that in addition to knowing they both give a C, one instructor gives the range of B to D, and the other one gives the range of A to F. So now not only do you know where their centers are, you also know the spread. So who would you take? It kind of depends, right? Would you take the B through D, or would you take the A through F? When would you take the B through D? When you knew you were going to be how in that class? When that class was going to be no, not easy.
Difficult.
When you know that class is going to kick your ass, because what does a B through D apparently never do? Never fails anybody, right? Some people have to fail. Sorry, it's the truth. And then what about the A through F? You're going to take that when you know you're going to kick that class's ass. Because I took this professor once, got the highest grade in the class, got a B for it. I'll never forget that. I'm a little bit, still, this is like 20 years. All right, you guys, some of you guys are like, I wasn't alive. Shut up. All right, you guys kind of with me? So that's, what extra information do I have there? The spread of the data. Okay, now, so that's what we want to figure out. This was all about, is there a way to measure where the middle is? Yeah, there's 4 ways. The way that wins is the way we know the best. That's why it won, or that's why we know it the best, because it won is the mean. Even though there are certain situations that you don't want to use the mean. Give me another situation where you would use the median instead. You could do it. Something about San Diego. You guys, anybody own a house? Have you looked at what it would take to own a house here? You could do this. You can do this.
At least like 7.
Yes, rough. Yeah, somewhere around there. Unless you want to live very questionable area, right? It doesn't cost much, but I might die this week. All right. So I would use the median. Every time you see this in this thing called a newspaper, every time you see them talk about home prices, they talk about the median. Why? Because there are definitely outliers in home prices, right? There are a big chunk like down here, and when I say down here, I mean centered around 500, 600,000. And then there's a few, like go to La Jolla. I like to go there and just look at all the places I'll never step foot in. Oh, that's beautiful. Up in the millions. You with me? So I would use median to be more honest. I would not use the mean. Okay, but the mean we use the most. We do. So that's the one that kind of wins. All right. So, stay with me now. Let me give you a few sets of data up here. So 3 separate sets of data. In fact, I'm going to tell you these are each population, something that students have a misunderstanding about. Population doesn't mean big. Population just means everything you want to say something about. So my population could be that row, right? And then I could pick a few people to be a sample from that row, although I wouldn't really need to. So those are 3 different populations. What are the means of each? Yeah, here's something kind of cool. This mean is obviously 5. What did I do from here to here? Made that go down by 2 and that went up by 2. That went down by 1, that went up by 1. So these still add up to be 25, so they still average to be 5. Everybody see what happened? And of course the same thing from here to here, down, up, still averages to be 5. So again, just like my teacher example, the mean by itself does not distinguish between the data sets. If I just told you the mean, you go, I think they're all the same. Shit. So I want one more number so that the 2 numbers are the best summary of the data. They distinguish between the data points. And I've got to tell you right now, it's not going to be range. What's the range of this guy? It's kind of silly. What's the range? What's the highest number? What's the lowest number? What's the difference? 5 minus 5. 0. Oh yes, don't scare me. What's the range here? 7 minus 3. 4. What's the range here? 4. Shit. So the range is different for these 2, but it's not for these 2. Are these 2 spread the same amount? Would you say that these 2 data sets are spread out the same amount? All right, so let's talk about what spread could mean. So, if I have a hurricane, and I used to live in Florida, so this used to be a daily thing in life with it. And yes, they would come and just park off the side of the venue. Are you guys watching the hurricane at all? Anybody have people in Florida? Are they okay, hopefully? All right. So you have a hurricane, there's a center of the hurricane. The eye, right? That's the assumed center. And then some hurricanes are huge and some are not so huge. Right? Okay. So how do I tell how spread out it is? It's kind of like how far away from the center it gets. Does that make sense? You can see that visually, how spread out it gets. So a little hurricane, oh, I should a little baby hurricane. And then you got this massive one that was out in the category 5 that some people apparently hadn't heard of. So it's spread out more from its center. So with what I just said, the way we look at spread in statistics is the way we look at it in a lot of situations in real life is just how far away from its middle does it get. Which one of those data sets has more numbers away from its middle between these two? C. So whatever we're about to do, we are going to create a formula. And we're going to take math and we're going to say, tell me what I want to know, math. We're going to create this formula. Whatever formula this is, the number that pops out for this one better be smaller than the number that pops out for this one if it measures spread. Because what did we just say? That's the most spread out. So we're going to create a formula that gives me a number that measures the spread. Bam. I like it. So let's do it. Enough talking, John. All right. So let me say what I said earlier. The spread, let me make it better what I said earlier. The spread is the average distance the data points get away from the middle. Let me say that again. Notice I'm saying it slowly and repeatedly. So it's a really good note. The spread is the average distance from the middle to all the data points. Just really absorb that statement and see how it makes sense to be the spread. Some of you guys, I love you guys, you're like, my notes are in my head. All right, fine. Okay. Say again, sorry?
Can you repeat just one last time?
Sure. The spread is the average distance from the middle to all the data points. So I'm not going to do the first set of data because it would be kind of silly. What would it be for this data? How far away from 5 does all the 5s get? 0. How far away from 5 is 5? 0. Please say that. How far away from me is me? If you say 1 foot, I'm like, what? Astral projection? No. So let me write this data down here. What was it? Yeah. So let me ask you this. So again, I said the definition of, if I wanted to find the average age in this classroom, what would I have to first get a list of? Age. Amazing. If I want to find the average left shoe size in this classroom, I'd have to first get a list of left shoe sizes. I say that because some of us might have differently sized feet. It just happens. Everybody with me? You're all like, duh. Well, what did we just say the number we're trying to create is supposed to be? The average distance from the mean to all the data points. So to find the average age, I need a list of ages. To find the average shoe size, left shoe size, I need a list of left shoe sizes. To find the average distance from the mean to the data points, I need a list of distances from the mean to the data points. Stay with me. I mean, you know, like in words it makes sense, John. I understand. So what's distance mean in algebra? Let's see if some of you guys say the thing I don't really want you to say right now, but would be true. What's distance in algebra? How do you find the distance between two numbers? Take the, how far apart are 10 and 7? 3. What'd you just do? Subtract. Thank you. So I want the distance between the data points and the mean. Why didn't I put an X bar there? Because these are populations and mu is for population. I like it. So what was the mu here, of course, was 5. So what do I put here? Which is? Keep going. You everybody with me? The mu is 5. So on the problem I'm going to give you, you got to first figure out what the hell the mu is before you can keep going. Negative?
1. 0. 1.
All right, that's very breathy. 0. Now, do you notice a problem with this? If I average those, what do I get when I add those together? What do I get when I add these together? 0. I always will get 0 because the mean will have equal amounts negative and positive around it. So it's going to come to 0. So that's great job, Jeff. Good job. We're following you and you get us to this frickin'... But there's a way to handle this. What's the problem with what we got? We have negatives. I was kind of hoping... I'm glad nobody did, but I'm sad nobody did. Somehow that both works. What really is distance in algebra, in math? Anybody know? There's a certain function that always comes out positive because it's based on distance.
Absolute value.
Yes, I like it. Absolute value, right? What's the absolute value of 3? 3. What's the absolute value of negative 4? 4. Why? Because absolute value is distance from 0. How far away from 0 is negative 4? 4 steps away. If I ask you how far apart are we, and I turn around and you say negative 4 feet, I'm like, are you in? You're in me? Sorry. Wait. No. Total recall. You guys kind of with me? So distance can't be negative. Now, we don't use absolute value here in a really quick, insufficient explanation, but still it's okay for right now. What does an absolute value look like? Don't do this. If I graph it. Yes, I love it. Somebody just went boom, boom. Absolute value 1 is 1. Absolute value 2 is 2. Absolute value negative 1 is 1. Absolute value negative 2 is 2. And it goes, So math really dislikes that. If you were in a plane that flew like that, you would be dead. Yeah, everything, boom. You're all just smushed against the side. That's a little too rough of a term. So in mathematics, we actually do call that a kink in the function. And we just don't like that much. So what's something else that will always have a positive output, unless it's 0, but doesn't turn that harshly? So it stays positive. Well, I just gave it away. What does this? Parabola. And where does it come from? When I, not absolute value of x, but x squared. Okay, good. I like it. So what we do here, so I can't, by the definition, I would add these up and divide by 5 to get the average distance, right? But if I add these up, I get 0. To take care of that, absolute value sucks, so I'm going to use squaring. So what am I going to have to do at the end? If these are number of dogs I own, I'm about to write down like square dogs. Do I want my dogs to remain little squares like they've been trash compacted? Oh, no. What do I want to do at the end? Undo the square, so I have to square root at the end. So why am I squaring right now? Just to kill the negatives in a nice way. All right, so what do I get when I do this? There you go. 4? Okay, you guys won't play along with me. So now let's watch. If I add those up and divide by 5, I'm going to get the average squared distance from the mean, and then I just have to, like I said, square root, and then I get the average distance from the mean. Yes, maybe? I really want you guys to follow me. So spread, definition, that makes sense, is the average distance from the middle to all the data points. So we are just doing the work that would make that happen. How do you find the average anything? I got to get a list of them, add them up, divided by how many there are. So I'm making a list of distances. Shit, they come out to be 0. Let me square them. I'm going to add those up, divide it by how many there are, and then take a square root, and that's going to be the average distance from the middle to the data points. So this is the process of developing a formula that does what we want it to do, right? We see this little formula. So, true. So that, now what would the symbol be for this? What do I put here? What's the symbol for what you just did to make 10? What did you do? Yes, I like it. You guys don't like to speak, so you can draw things in the air. Sum of what? What did you just add up? No, you didn't add up the x's. That would be here. You added up x minus mu squares. I like it. So if I take the sum of x minus mu squared divided by n, that'll be the average squared distance. And then I square root it. That isn't done yet. I haven't taken a square root yet, right? But it is a thing. It's called the variance. And the symbol for it is sigma. Oh, shit. The E was capital sigma. This is lowercase sigma. Little baby, little fat baby, right? Well, depending on my mood, I either make it a skinny baby, fat baby. It's a baby because it's lowercase. All right, just go with it. Don't make it an R because R means something different later. Try to make it. So start at the chin, work around the belly, come up to the hat, whatever the hell it is. Little creature. Okay, maybe. All right, now I'm missing something. We do this just to remind us that we haven't taken a square root yet. So the variance is sigma squared. The spread, which we call officially the standard deviation. Dude, some of you guys said that with me. I like that. Which kind of makes sense. What's deviation mean? What's it mean to deviate? If the hurricane deviated from the path I thought I was going to take, that means that... Anybody know what the word deviate means? Huh? Moves away from. So if there's something I expect, an average I expect to happen, and I don't get that, I've deviated from the average. Isn't that what these are? How much did a data point deviate from the average? And that's the standard deviation, because I've averaged those up together. So this will be sigma equals the square root of this shit here. Oh, shit. So how do I get the variance? What goes in place for all that? What is that thing? 10. Why can't I plug something in here for x? What is x? All those numbers. Where'd it go? Here. All those numbers. I can't. Let me put 3, 4, 5, 6, 7. Yeah, it's that. No, stop it. This entire thing is a sum of stuff, so it is a number. That whole thing is a number. We know it's 10. What's n? 5. So for the variance, I get 2. What do I get for the standard deviation then? And we know what the square root of 2 is? I do. Yeah, that's useful. Does that help you buy lettuce? No, shut up. 1.414, I like it. Always, oh shit. Here's another note. Standard deviation must be rounded to at least 3 decimal places, if not more. 3 decimal places or more. Maybe not 8, don't go crazy. But at least 3. Later this semester, there's something we're always going to do to 4 places, so you can just make everything go to 4 places and cover your ass the whole semester. All right, if you want to. So before I give out this little handout that covers this, maybe don't even write this down. Well, let's see how you figure out to do this. What did we say earlier? The number we just got, 1.414, is the number I would get for this one bigger or smaller than that? Bigger, because this one is more spread out. So real quick, don't even, if I did put that data in here, right? 3, 7. This would have been 2, 2. This would have been 4, 4. You can already see it's getting bigger, right? 4, 8, 12, 16. This would have been, whoop, 16. This would have been 16. This would have been, what is it, Jeff? 3.2. And the square root of 3.2, I don't know. You guys with me on that? I'm sorry. I didn't want to do the whole thing over again, but what is it? Sorry? 1.788. Which is not much bigger, but it is bigger than 1.414. So it does distinguish between the spreads. So if I told somebody I have an average 10 and a standard deviation of 5, that kind of is spread out a lot. If I said I have an average of 10 and a standard deviation of 1, that's much skinnier. It's not nearly as spread out. So if I said the average quiz grade was an 80 with a standard deviation of 1, that would be weird as shit. That never happens, because that would mean that most people scored between 78 and 82. You didn't get very far away from the average. What normally happens with quizzes is the average and something in the standard deviation is like 14. Because you get some people with 100, some people with 20s, and a lot of people in the 80s and 70s, right? So the spread is kind of bigger. Yes? Oh, sorry. Yeah, let's do it again, everybody. Start at the chin, go around the belly, and then up for the cap. Shwa! Shwa! If you try to do it the other way, it looks really weird. So don't do it the other way. And don't make it an R. Just learn how to make that little thing, please. All right, let me give you this. Here's the neat thing about this. Not only that it has these holes that I really didn't want, but you got one side has a fully worked out example. And the other side has, of course, a blank one that you're going to work on. And before I give this to you, I'm going to finally remember to say this before I hand this out. It's not over yet. Hold on. Oh, shit. What was all this for? What were these? Populations. All right. There's a remarkably little tiny thing that happens to the equation if it's a sample. Let me see if I can make it make sense. There's an average age in here currently, right? Yes. And everybody is some distance away from that average age. So if the average age is 21, and you're 24, you're 3 away from 21. You with me? No? What happened? Yes, okay. You're like, too early to shake my head. All right. So everybody has an average. So if I took one row and took their average, I would put money on that average being different than the average of everybody, right? Let's just say the row I picked happens to be younger. So the average age for everybody is 21, and the average age for this row is 19, let's say. You guys with me? Are the people in this row going to be closer to their own average